Today I just wanted to go over a few of the simple math review operations we have in POE. I'm going to try to follow straight through like we did with the Google slide presentation. So we're going to start with order of operation. So in our first example we see we have parentheses. You always start with parentheses, you do what's inside first. Then we have multiplication and we have addition and subtraction. You always do multiplication before you do the other two. So we have 6 times 2 is 12, and then the 2 and the plus 2 and the minus 4 all stay together. Okay, now still within the parentheses is 2 plus 2 plus 12 is 16 minus 4, so we come back to 12. Then it all still times that 2. So 2 times 12 is 24. So it's as simple as that. On the next example, we have parentheses again, so we start there. 3 plus 6 is going to be 9. We're going to still multiply that by the 8 and by the 3. And the 8 has the 5 minus 1 underneath, which do multiplication first. So 8 times 9 is 72. 72 times 3 is 216. We still have the 5 minus 1. Now technically we should do the division now, but it's really impossible to do division of this with this operation in there, this subtraction. And so we really have to do this. So it'd probably been best or a better practice to put that in parentheses. And so we have 216 divided by 4. 4 goes into 21 5 times, 1 left over, so 4 goes into 16 4 times, and we have, we have our answer of 54. So that's order of operation. Next we're going to move on to slope. Slope, if they didn't give you any points to work with, and they just gave you a line on a graph like this, you try to pick points where they cross nicely. So we're going to pick this point, so that is over 3 and up 2, so my ordered pair is 3 2. And then along this way, that one's pretty close. I think this one's even better though. So I'm going to go with this one, and x, y's were negative 5 and y's minus 1. So negative 5, negative 1. And then for slope, remember it's rise over run, or the change in y over the change in x. Change in means the final position, or the second position, minus the initial, or the first one, and the x the same way. Second one minus the first one. So the second one is the 3 2. So for y we have 2, and then down here at the first one we have negative 1. So 2 minus a negative 1, and then on the bottom the second x is 3, and then we're subtracting from that the first part, which is negative 5. So 2 minus negative 1, or 2 plus 1, is equal to 3. 3 minus negative 5, or 3 plus 5 is 8. So our slope is 3/8. Okay, let's do one more slope really quick. On this slope, find 2 points. That one looks pretty good right there. And maybe this one right here. Okay, so on this one, we assume we're headed down this direction. We're always moving from left to right in this direction. So again, we're going to have our y's, change in y, over our change in x. And so if we find these two order pairs, the x on this one is 2 and 0. So right here we have 2, 0. And up here at this one, we have negative 1 and positive 2. And 2. Oops, that was quite the parenthesis there. And so our second point is this lower one now. So the second y is 0. So we're going to have 0 minus, and the other y is 2. And then on the bottom part, we're going to have the second x, which is 2. And the first x was negative 1, so minus a negative 1. And when we do all that, 0 minus 2 is negative 2. 2 minus a negative 1 is 3, and so our slope is negative 2/3, and that makes sense. A negative slope is headed down, where a positive slope over here was headed up. Okay, so let's go to exponents. When you're dealing with exponents, basically we're going to look at all the numbers by themselves, and then we're going to look at each variable by itself. So it's kind of like 2 times 4 times 3, 2 times 4 times 3. And then we have our x's, so we're going to have our x, but now when we have exponents, when they multiply exponents, you just add the actual exponent. So it's going to be 2 plus 2 plus 1, 2 plus 2 plus 1, there's an implied 1 there. And then for our y's, we're going to have 4, 4, and nothing. So we're going to have y and 4, and we'll just add those two together. Okay, so let's just do the top to start with. 2 times 4 is 8, times 3 is 24, and then x to the 5th, 2 plus 2 plus 1, and then y to the 8th. Now that is all going to be over this 3x to the negative 3 and y squared. So now if we combine those, it's going to be 24 divided by 3 for the numbers. It's going to be x to the 5. When we divide, we subtract, minus a negative 3. And then your y is going to be 8 minus 2. Oops, blending into the next problem over here. Okay, so when we do this, 24 divided by 3 is 8. 5 minus a negative 3, so x to the 8th. Y 8 minus 2 is 6. And so our final answer is 8x to the 8th, y to the 6th. Sorry, we kind of blended there. Okay, let's do this other one. Now on this one, you could try to combine all these, but anything to the 0 power means 1. So if you do what's in the parentheses, if you just look at this, it's just going to mean this on the top is 1. And then we have that over 2h to the negative 3, j to the negative 4, k to the negative 2. You could leave your answer like that, but if you like everything in the top, which is sometimes nicer, really, this h, there's h to the 0, there's j to the 0, and there's k to the 0 still up here. And so when we combine these things, we have the numbers 1 over 2, and then we have h to the 0, and then we can subtract minus the negative 3, and then we're going to have our j. Okay, and so our j is going to be 0 minus a negative 4, and our k is going to be k to the 0 minus a negative 2. And so when we do all that together, we're going to get h0 plus 3 when we put that together, so h cubed, j0 minus a negative 4, so j plus 4, or j to the 4th, and k 0 minus negative 2, so k to the 2nd. And then don't forget, all of that was multiplied by this 1/2, or all of this stuff is divided by 2. Didn't hardly leave enough place. Okay, hopefully that makes sense. Now let's look at scientific notation. So far, hopefully you see that math in this class is really not that hard. It just gets more complicated because we combine a lot of these things all in the same equation. It's not simple where we just do one thing at a time in here. This one we're going to convert it to scientific notation, so we're going to move our decimal so there's only one number to the left of the decimal. So 9.435, unless these are significant, we leave off those placeholder zeros. And then we move this thing 1, 2, 3, 4, 5, 6 places over. So it's 10 to the 6th. Do the same here, move our decimal over, so 5.41. And now we moved our decimal the other direction 3 places, so times 10 to the negative 3. We can go in the opposite way, where we take things and we put them away from scientific notation. So we're going to have our 6.75, and we're going to go to the negative 4. So we're going to move 1, 2, 3, 4 to the left, put our decimal back, fill in the spots with placeholders, and get 0.000675. That would be our answer. And on this one, 3 times 0.2 times 10 to the 6th, we're going to have 3.2, and we're going to move that 1, 2, 3, 4, 5, 6 places, put our decimal back, fill in those empty spots, and we get 3,200,000. Again, not too hard, I don't think. Now this is how you might see it more in this class. A lot of times we might use milliamps, is fairly common, so we do electricity. I put grams here, but it doesn't matter what this part is, it's the milli that we're concerned with. So milli means 10 to the negative 3, so this is 98 times 10 to the negative 3, and that would now be grams. Or milli is 1/1000th, so you could have 98 over 1,000 grams. Both of those mean 0.098 grams. So that's 3 different ways to write the exact same thing. This is the nice one to put in our calculator. On this one, we have 7.6 megameters, 2 meters. So mega means times 10 to the 6th, so 7.6 times 10 to the 6th, or you could write it out as the big number, and both of those will still be meters. So that's scientific notation. Again, we don't use it a lot, but it's good to know. Alright, isolating a variable. That's one of the most important things we do in here. I didn't give you any typical ones that we might see, but if you can move things around on something like this, you can move things around anywhere. This is just algebra. Most of you had algebra back in 8th grade. Okay, so you should know this stuff. We want to get the x by himself, so this is the guy we're looking for. So first we have to kind of get him out of this little prison he's in with the parentheses. We're going to multiply this out, and 3 times negative 4 is negative 12. 3 times 16 is 48. Still equal to the 36 minus 12y. We've got to get rid of this 48 that's next to the x, so we're going to subtract the 48 because that's the opposite. So subtract the 48 on this side. If you do it to one, you must do it to the other. Okay, so now when we subtract, we have negative 12x equals negative 12 minus 12y. Now we're going to divide by that negative 12 because it's multiplied, so it's opposite to get rid of it. That means we have to divide this side by negative 12. We could factor that negative 12 out of both of those things, right? Have negative 12 is 1 plus y, and then the 12s go away. Or if you see this, since 12 in every term, same thing, we can just cancel it out of there, and there's 1 left over up here, and then we have that plus y over there. So it doesn't matter which way you do it. The negative 12 cancels. I don't know if your math teachers force you to bring it out of there or not. Okay, same thing over here. We're going to solve for x. Paper so it fits on the page here. So again, we got to get this x out of this little prison in here, so we're going to multiply through. 4x minus 4y is equal to 12. Okay, when we get to x by himself, we're going to get rid of 4y, so we're going to add because that's the opposite of subtract. So we're going to add 4y to this side and get 4x equals 4y plus 12. Okay, now we want to get rid of the 4, so we're going to divide by 4, divide all this side by 4. And we have the x is equal to, and you can see the 4 goes away on that one, and 4 out of this one leaves 3 left over. And again, you could have factored that to say 4y plus 3 over 4, and it works the same way. Easy peasy. Okay, let's move on. The last one, this is probably the most complicated just because it's the last thing you've done. So in geometry, Pythagorean Theorem, you probably did that way back in 6th, 7th, or 8th grade, a long time ago. So this one, we're just looking for this hypotenuse. Remember this a squared, and well, this is just a and b and c, but a squared plus equals c squared. Okay, so c is equal to the square root of a squared plus b squared. So I think all of us know this, so I'm not going to spend much time on this. So this would just say that this is the square root of 5 squared plus 14 squared. And that one I cannot do in my head or with paper, so we'll get out our fancy calculator here. Oops, use the calculator, not home screen. Clear everybody off, and we do square roots of 5 squared plus 14 squared. And we get 14.866. Typically in this class, we like to, if you don't tell us otherwise, we usually go about to hundreds place, so it'll be 14.87. And done. And then I think you can do this one. This is now maybe the a side, so we're going to have the a equals c squared minus b squared. Right, if this is c, this is b, and this is a. Okay, I think you can do that, so I'm not even going to do that one. Move along. Okay, now we're down to our sine, cosine, tangent functions because we want to find one side, knowing one side and an angle. Okay, so you have both sine is opposite over hypotenuse, so, and they have ka, which is cosine is adjacent over hypotenuse. Well, in this case, we know that this is the hypotenuse. We know this side is adjacent because it's right next to this angle. Whatever's next to the angle is the adjacent, so that's the a, and this guy over here is the O. We don't care about the O in this case because we don't know anything about it. So since we have the A and the H and an angle, we're going to use this guy here. So we can say that the cosine of the angle is equal to the adjacent over the hypotenuse. That's the actual equation that comes from this little SOHCAHTOA thing. Well, we're looking for A, so we want to get A by himself. So again, we're just finding the variable. So we're reviewing again. We want to get rid of the H, so we multiply both sides by H. When I get h times the cosine of the angle is equal to the adjacent side. Well, h was 12 times the cosine of the angle, which was 54, equals the adjacent side. Okay, now when we do this, make sure on your mode, if you have one of these kind of calculators, oops, make sure you're in degrees. Right, so let me find that. You just hit this mode button, and it shows you. If you have one of the simpler calculators, just scientific, it'll usually say, kind of down here at the bottom, it will have RAD, DEG, and GRAD. Radians and gradians, we don't care about. The DEGs, the degrees that we want. So just make sure you have degrees no matter what one you're at. We always work in degrees, right? Because this is in degrees right here. Over here. Alright, so let me clear that thing there. So now we're going to have 12 times cosine of 54. We do that and we get 7.053 or 7.05. Alright, not too bad. Let's try another one over here. On this one, we know this is the hypotenuse. This is the adjacent side because it's next to the angle that we have. And then this is the side opposite. The one we look across, that's the opposite. So this is the O. So now we have opposite and hypotenuse, so we're going to use the sine function. So the sine of the angle is equal to the opposite over the hypotenuse. Again, we don't want the sine, we want the opposite side, so we're going to get rid of the hypotenuse off of this side. Goes away, and we have that the hypotenuse times the sine of the angle is equal to the opposite side, which is what we're looking for. The hypotenuse was 18, the angle was 46. Again, let's look at our calculator here. So we're going to have 18 sine of 46. And we get 12.948 or 12.95. Okay. And then our last one down here, our last two. In this case, we're looking for the angle. So this is the hypotenuse, this is the opposite side, this is the adjacent side. We have the opposite and the hypotenuse. That was the sine function. So in this case, we're going to say the sine of the angle is equal to the opposite over the hypotenuse. Well, in this case, we're looking for the angle, not the sine of the angle, but the angle. So we've got to get rid of this sine function. The opposite of sine is something called inverse sine. On your calculator, or where you see it, it's just this little sine to the -1. If I do that to both sides, it gets rid of it. But I have to do it over on this side as well. So I have to add this little sine to the -1 on this side. So we end up with that the angle is equal to the inverse sine. Oops. Get my 1 in there, of the opposite over the hypotenuse. And so now the angle is equal to the inverse sine. Opposite was 34, and the hypotenuse was 55. So now if we put that all in our calculator, we get that the second, so you hit the second button and then sine, and you get the sine inverse, 34 divided by 55. And we get that it's 38.18 degrees. If they give you units, you should always put units. So in this case, they gave degrees as unit, or units as degrees. Okay, let's try another one just like that, because this one seems to be like the hardest because that inverse, we're not used to using that. So in this case, this is the hypotenuse, this is the opposite side, this is the adjacent side. We have the hypotenuse and the adjacent side. Remember, that was cosine. So the cosine of the angle is equal to adjacent over hypotenuse. We want to get rid of the cosine, so we're going to do this cosine -1. So on this side, we're going to do cosine -1. They go away on this side because they're opposite of each other. And so the angle is equal to the inverse cosine of the adjacent over the hypotenuse. So that's equal to the inverse cosine. Adjacent was 52, and the hypotenuse was 56. So now if we do this one, lots of glare going on this one. We do second cosine, which gives us the inverse cosine, 52 divided by 56. And we get 21.786 or 21.79. So there you go. There's an examples of all the stuff. Other than we put all kinds of stuff together, that's kind of the math for this class. So good luck. I think you'll do fine. The class isn't that bad. Don't stress.